For this recording, I'm going to go through the 7A class activity. Before I jump into that, I want to talk a little bit about anchoring cells. To do that, I'm going to, let me explain what that means. When you anchor a cell, that is holding the column or the row constant. And by way of example, let me show you what happens when you don't anchor a cell. So in cell E5, I created a formula that equals A1. That's the value of A1. If I were to copy that over and paste that formula next to it, so when I copy this right here and paste it into here, and that's now B1 and then C1. If I go down, so that moves over for different columns. If I copy these down, the same formulas down here, you'll notice that in reference to the first formula, it's now A2, A3. So it's going down in the column to the new row because the rows aren't anchored either. And the way you anchor a cell is you put a dollar sign. So I'm going to anchor the column. That's the letter here. I'll put a dollar sign in front of the column. And then, so if I were to copy these over to the right, the same column is held constant. We're still in row one. So A1, A1, all of these are A1. You'll notice the row itself is not held constant. So if I were to copy these down here, you have the next row. So that's A2, A3. And likewise, the same thing, if we were to hold the row constant, but not do anything about the column, when we copy that down, let's see, I'll copy this down to larger. We're still on the same row because the row is being held constant, but here the column is not. And so all of these values are 1, 2, 3. Another option is that we can, if we put the dollar sign on both the row and the column, the little shortcut is if you hit F4, it has that, no matter where you copy this, how far down, the rows and the columns are held constant with that dollar sign because they're anchored down and it won't ever move. And this could be handy if you have a table and you want to reference a value in a specific value for it that's set in the cell. You can anchor the cell reference as part of that formula. So no matter where you move, whatever row or column you are, you can hold those things constant. And we'll use this little thing, anchoring in a few of these examples here. Okay, let's move over to skill practice worksheet. Let's start working on this. The very first example we have is there's a young man who is going to be saving up for his mission. He's 12 years old and he's going to put $25 every month away towards his mission. We're going to do a little bit of math here. So how many years he's going on a mission when he's 18, that's the plan. So 18 minus 12 is 6. You can put a formula in here. So we'll compute that for you. So we have 6 years. He's putting away $25. That's the value we have there. His APR, his annual percentage rate, is 2%. So now let's use the future value function. The future value function will tell us how much money he'll have in 6 years. We'll do that by FV, interest rate to 12. You divide that by 12 because he's making payments for every month. And then you have, that's rate, the N per are the number of payments. So 6 years times 12. And the payment he's making, and we'll put a negative sign in front of this, so negative 25. These formulas are actually written for accountants, and they do things a little bit backwards. And so if you don't put a negative sign in front of the payment amount, it will give you a negative value. At the end of 6 years, Ethan's going to have $1,910.76. How much money did he contribute? Well, he made payments for 6 years. He made payments every month. And so we have 6 times 12. And then the payment he made was $25. So So he paid $1,800. And how much is the bank going to give Ethan? What's the interest rate? The total interest on this thing. I'm going to reference this cell right here. We have $1,800 because that's how much money. Actually, let's go to the future value. That's how much money he'll have at the end of the period, and he contributed that much, $1,800. And so after 6 years, he has $110.76 more than had he just stuck that money under his mattress or in a jar. That's the interest that he had. Let's take a look at Sydney. She's almost getting ready to graduate. She ran out of money, so she took out a student loan for $2,800 for her last semester. And she knows she's going to have to start paying back the bank or the lending institution 6 months after she graduates. And the terms of the loan are 10 years and 4.75% interest. Oh, the loan amount. Let's put it in the right cells. 4.75% interest, and she's borrowing $2,800. And the payment function to calculate what her monthly payment obligation is for this type of a loan equals PMT. The interest rate is right there, 4.75 divided by 12, because she's making monthly payments. It's 10 years times 12 because those are, well, monthly payments. Present value negative 2,800. That's what she owes. That means she has a monthly payment of $29.36. How much is Sydney going to pay? Well, she's paying over 10 years. So that's 10, and each month times 12. And the amount she's paying is what we calculated over here, 29.36. That means she's paying $3,522.88. And how much is the bank going to charge Sydney? Well, it's the amount she paid minus the loan amount. And so for having borrowed $2,800, she's paying the bank $722.88. Let's look at the last exercise on this worksheet. The Munyariris are buying a home. They talk to their lender and they're getting a 30-year note. The loan amount that they're borrowing is $210,000. The interest rate is 4%. And if you're doing that, right now, the interest rates, I think last I checked, are something like less than 2%. But anyways, let's figure out what their payment is according to this type of a loan. Interest rates can fluctuate. Right now, they happen to be particularly low. The payment function equals PMT. The interest rate is 4%. We divide that by 12, 30 years, and it's monthly. So that's 360 or 30 times 12. And the amount they're borrowing is $210,000. And I'm just going to reference the cell D18 and put a negative sign in front of there. And that's what the monthly payments. Well, I'll show you, if you don't put a negative sign, it'll give you a negative value of what they owe. And how much will the Munyarari family pay if they only make minimum payments? Well, it's 30 years times 12 times their payment amount. And so that's almost 361,000. And what is the interest that they're paying the bank for this type of the privilege of having this loan? That's the 369.2596 minus 210,000. So that loan is going to cost them almost $151,000 if all they do is make minimum payments. Let's start filling out this loan amortization table. The loan amount is the beginning balance. And before you pay down the loan, when you make your payment, the first thing you pay is the interest. The bank always gets their money first. And so let's do that's the beginning balance times the interest divided by 12. And we are going to anchor this cell by putting the $ there in front of the row. And so that first month, when the Munyariris pay just over $1,000, $700 of that is going towards the bank for interest. And the balance of their payment is going towards the principal to pay down the loan. So let's put a dollar sign in front of the 20. That's the row, because we're copying this straight down. And the ending balance is the beginning balance minus the amount that they paid towards the principal. So that's $209, $209,697.43, which is the beginning balance of month 2. And you do the exact same thing for the second month. And this time, because it's a smaller beginning balance, you'll notice that the interest they paid is a little bit less. And the principal that this family is paying is a little bit higher, and that pays down their balance a little bit more. And you could bring this down to right there, and that'll give us the first 5 years. Excel has a pretty good recognition capabilities. So if we were to grab all of these cells right below the first one, because the same formulas we're copying down, the reference formulas, we can drag this all the way down to 360. That might be too far. Yep, that is too far. That's okay, we can delete these. There at 30 years, if you finally have a balance of $0, everything's all paid off. Okay, so there's the skill practice. Let's take a look at an application of this. There's a young woman named Addie, and she just borrowed some money, or she got $200 from her as a birthday present, and she decided she's going to put some money away for savings, which is a great thing to do. But she has a principal. She starts out with a principal of $200. She's going to start adding. You pick some number between $15 and $75. Let's start off with 75. We can toggle that in a minute. From the bank, she gets an interest rate. Let's see, she has, I think it's pretty high, 2.25%. You're not going to see that in any bank in this day and age. So if you do see that, definitely jump on top of that, because right now I think we're about half of 1%, something ridiculously low like that. And I put this formula in here already. The future value, you have the interest rate divided by 12, the number of payments, and then she's making payments of $75. So that's this cell right here. And then there's this in this column, in these brackets, these are things that you can put in there. So if she has a present value, an initial seed money that she's starting out with, $200, in this case, you can put that in there. So minus 200, or you put in that referencing the cell that has $200 in it. And so after 3 years, she'll have that much. And the handy thing about having that Excel function there is that we can use that to check our work. Just like we did with a skill practice, the initial principal is $200. The interest payment is that divided by 12 times that. And so let's anchor down the interest rate. And so she got 38 cents in interest the first month. She makes a payment of $75. And so now let's add up all of the money that she has, the principal, interest, and payment. At the end of the first month, she's got $275. And that will be what we put right there. And I'm just going to copy this all the way down. The interest, we have that. We can copy this all the way down as well. I'm going to lock this down, anchor it, so I can copy that. And this one I can just copy down. So now we have the same value, $3,004.46. If you want to add up all the interest, let's put a sum function, and I'll say shift control up. Oops, there we go. So Now you see there's $104.46 of interest. But if you wanted to see what happens, oh, actually, I'm just going to reference that cell right here. So you can see what happens if we start toggling that amount. So if instead of making $75, she makes $15, that's just $32 of interest and a nickel. And she'd only have $772.05 at the end. Let's move that payment back up to $75. And so you can, whatever amount you put in there in between, this will adjust. And great. And then you have some, explain your monthly goals for annual, why you picked the amount you did, and you think about that, and then you'll be able to complete this exercise.